Hey everyone, this is the last bit of our linear equations and graphs. So this is another word problem. Two garages each charge a fixed amount plus an hourly rate to service a car. We have two separate garages. So we have Main Street Garage, and this is supposed to be customer. It charges one customer $153 for a 2-hour service appointment, and it charged the second customer $315 for a 5-hour service appointment. Okay, so and then garage 2 charges $5 less per hour than the garage on Main Street and 10 more than the fixed amount. So the question is, which I usually read first, how much would the garage on the 2nd Street, which is the second one, charge for a 3-hour appointment? So basically, let's look at this. You have to take a few seconds to plan a route to the desired quantity. For example, before you can determine the amount that the garage on 2nd Street would charge, you'll need to find the hourly rate and the fixed amount charged by the garage on Main Street. So we have to think about the aspect of the linear equations. So in a real-world scenario, a unit rate, which here is the hourly rate, so the unit rate equals the hourly rate. These are both rates. All right, so basically we're using we've got 2 points. We have our, for 5 hours, it's $315. Let's do the first one. So for 3 hours, or 2 hours, my output is $153. And for 5 hours, it's $315. So let's find the slope, or the unit rate, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to do 315 minus 153 over 5 minus 2, which gives me 162 over 3, which equals 54. Okay. So the garage on Main Street charges $54 per hour. Okay, now, since we have that, we have $54 per hour. All right. Now, the garage on 2nd Street charges $5 less per hour. So that's $54 minus $5, which gives us $49 per hour. So this is Main Street, this is 2nd Street. Now you need to find the fixed amount charged by the garage on Main Street. So if a customer was charged $153 for 2 hours, and the hourly rate is $54 per hour, then the fixed amount is going to be 153 minus 2 times 54. And you can put the dollar signs in if you want. I'll go ahead and put them in. So that's dollar, and this is dollar. All right, so this is going to be $45. All right, because that's 2 hours. Now, the garage on 2nd Street charges $10 more. So all you do is put in $45 plus $10 equals $55. All right? Now, putting these two pieces of information together, the garage on 2nd Street would charge $55. And take that, plus 3 times your $49. And that gives you $202 for a 3-hour service appointment. Okay? Okay, and the okay. Now, we have an equation here, and they said if the equation has infinitely many solutions, then what's the value of a minus b? And what I forgot to do is write the equation down, so let me quickly write it down. So we have 1/2 6x minus 4 minus 3 minus x equals ax plus x plus b. Okay, so the first thing we're going to do is simplify both sides of the equation as much as possible and then figure out what we've got. So let's just clean this up a little. So we get 1/2 of this, which means we get 3x minus 2, and then I'm going to take care of this part, minus 3 plus x equals ax plus x plus b. Now I can clean this up a little bit more, and we get 4x minus 5, and here I want these to look the same, so basically I'm going to factor out an x. You get x times a plus 1 plus b. Now, for the left side of the equation to equal the right side, the coefficient of x must equal the same. So basically, these two should equal here. So basically, we're going to set a, so my x's, these are my coefficients, 4 and a plus 1. So I'm going to set 4 equal a plus 1. So a equals 3. Now b, we already know if we set those the same, b already equals negative 5. Remember, we want this, the right side to look like the left side. And now what are they asking? What's the value of a minus b? So we have a minus b equals 3 minus a negative 5, which equals 8. Okay? That's all. Thank you and have a nice day. The next set we're going to do is systems of linear equations. Bye-bye.